So let's start with this exercise. We are asked to calculate the limit around 0, of this function of two variables, x cubed plus y cubed over x squared plus y squared, using polar coordinates. So I told you during last session that sometimes using polar coordinates simplify our life, help us to calculate easily limits of functions of two variables. What's the idea behind the polar coordinates? So if you have Cartesian plane, Cartesian coordinate system, if you take a point on this system, let's say a point xy, so this is x on the x-axis, this is the value of y on the y-axis. We can express this point in what we call a polar coordinate system, okay? And this, how it works. So it works like that. So if this is the angle formed by this half line connecting the origin to the point xy and the positive x-axis. So this angle is theta in radian. The distance between the origin and the point is r. The couple r theta is called the polar coordinates of this point A, let's say, of A. Okay, and what is the relation between the Cartesian coordinates and the polar coordinates? Here, for example, we can use the right triangle. We know that cosine theta is, what is the formula for cosine? It's adjacent over hypotenuse, if you remember this. So the adjacent is this length, which is x, and the hypotenuse is this length, which is r. Okay, so we end up with this relationship, x is r cosine theta. And in the same way, y will be r sine theta. So this is the relationship, how to go from polar coordinates to Cartesian coordinates. Okay, now what happens when xy go closer and closer to the origin, to the point 0, 0? So when we are going to 0, 0 through this path, in polar coordinates, this works in this way, making r going closer and closer and closer to 0, 0. It's like a spiral. Okay, so the distance r is going to 0. It's positive, if you want to be more precise, to 0 plus, but we continue to rotate. So theta will this angle will continue to rotate. So theta will vary when xy goes to 0, 0 at the limit. This corresponds to the fact that r goes to 0 plus. So if we want to rewrite this limit in polar coordinates, we'll say that it's equal to the limit when r goes to 0 plus. So this replaces the fact that the point xy goes to 0, 0 to the origin. X cubed, we replace x by r cosine theta, so we get r cubed cosine cube theta plus y is r sine theta, so it's r cubed sine theta over r square sine cosine square plus r square, here sine cube and here sine square. This is y. So we rewrite our original limit in polar coordinates, and now we want to calculate this quantity when r tends to 0. Okay, so how can we do this? Of course, first things to do before doing all this, you have to replace by 0, 0 and see whether we can calculate directly the limit or it's indeterminate form. Okay, so here it's clear that if you replace x by 0 and y by 0, you get 0 over 0, which is an determinate form. Okay, and to get rid of the indetermination, we have at one of the steps, we have to make a simplification. Okay, so to make simplification, first let's see whether we can factor the numerator. So is there any common factor here in the numerator, guys?
We can take r cube, doctor.
R cube, here we have r cube and here we have r cube. Okay,
yes.
So common factor is a common variable with the less power. Okay, so here the 2 power are equal, so r cube is common. يبقى cosine cube plus sine cube over r square cosine square plus sine square theta. What do you think about cosine square plus sine square? The same angle theta. This is
this is 1, son.
This is 1. This is Pythagoras.
1.
Okay.
Yes.
And we have r cube over r square. Can we simplify?
تروح السكوير مع 3 يبقى 1 only.
تبقى عندنا r in the numerator.
Yes.
Cosine cube theta plus sine cube theta, and in the denominator we have 1. So finally this is the limit r0 plus of r cosine cube plus r sine cube theta. Okay, so we simplified, we convert our limit to polar coordinates, and we end up with this simplified form. So let's check now whether we can calculate this limit when r goes to 0. So when r goes to 0, r times cosine cube. So we know that cosine is a quantity between -1 and 1. And same for cosine cube. So r cosine cube will be between r and minus r. And it's clear that when r goes to 0, minus r also goes to 0. So this quantity محصورة between two functions going to 0. So it's clear that this limit is also 0 when r goes to 0. We can say the same for this term. So finally, this limit exists and it's equal to 0. Okay? Any question about that? So this is a way how to calculate limits of function of two variables in the case the limit exists.
واضح
اوكي، سقوط علامة الرضا.
السؤال يا دكتور واضح.